Hi everyone. Today we're going to study Euclid's division algorithm. Let's begin with Euclid's division lemma. Given positive integers a and b, there exist unique integers q and r satisfying a equals bq plus r. R is greater or equal to 0 but less than b. The a is the given integer, b is the divisor, q is the quotient, and r is the remainder. Now let's proceed to Euclid's division algorithm. Euclid's division algorithm is a technique to compute the highest common factor, or HCF, of two given positive integers. To obtain the HCF of two positive integers, say c and d, with c more than d, follow the steps below. Step 1. Apply Euclid's division lemma to c and d. So we find whole numbers q and r such that c equals dq plus r. R here is more than or equal to 0 but less than d. Step 2. If r equals 0, d is the HCF of c and d. If r is not equal to 0, apply the division lemma to d and r. Step 3. Continue the process till the remainder is 0. The divisor at this stage will be the required HCF. Note that given two positive integers c and d with c more than d, then c equals dq plus r. We say that r is more than or equal to 0 but less than d. This algorithm works because HCF of CD equals HCF of DR. Example 1. Use Euclid's algorithm to find the HCF of 4052 and 12576. Step 1. Since 12,576 is more than 4,052, we apply the division lemma to 12,576 and 4,052. That means we divide 12,576 by 4,052. So we get 12,576 equals 4,052 times 3 plus 420. Step 2. Since the remainder 420 is not equal to 0, we apply the division lemma to 4052 and 420. So we have 4052 divided by 420. So we get this equation. 4052 equals 420 times 9 plus 272. We consider the new divisor 420 and the new remainder 272. So we divide 420 by 272. So we get this equation. 420 equals 272 times 1 plus 148. We consider the new divisor 272 and the new remainder 148. So we divide 272 by 148 and we get this equation. 272 equals 148 times 1 plus 124. We consider the new divisor 148 and the new remainder 124. So we divide 148 by 124. So we get this equation. 148 equals 124 times 1, then plus 24. We consider the new divisor 124 and the new remainder 24. We divide 124 by 24. So we get this equation. 124 equals 24 times 5 plus 4. We consider the new divisor 24 and the new remainder 4. We divide 24 by 4. Then we get this equation. 24 equals 4 times 6 plus 0. The remainder has now become 0, so our procedure stops. Since the divisor at this stage is 4, the HCF of 12,576 and 4,052 is 4. To summarize, this is what we did. This 12,576 divided by 4,052. We get this equation. 12,576 equals 4,052 times 3 plus 420. Now, this 4,052 divided by 420. So we get the second equation. 4,052 equals 420 times 9 plus 272. The remainder is not 0, so we continue the process. 420 divided by 272. We get the third equation. 420 equals 272 times 1 plus 148. Then we divide 272 by 148. We get the fourth equation. 272 equals 148 times 1 plus 124. Then we divide 148 by 124. We got the fifth equation. 148 equals 124 times 1, then plus 24. Then we divide 124 by 24. We get the sixth equation. 124 equals 24 times 5, then plus 4. We divide now 24 by 4, we get the last equation. 24 equals 4 times 6 plus the remainder 0. We stop here because remainder is 0. And we say HCF of 12,576 and 4,052 is 4. Example 2. Show that every positive even integer is of the form 2q, and that every positive odd integer is of the form 2q plus 1, where q is some integer. Let a be any positive integer and b equals 2. By Euclid's algorithm, we write a equals 2q plus r. For some integer q more than or equal to 0, and r, the remainder, equals 0, or the remainder r equals 1, because r is more than or equal to 0, but less than 2. So we write a equals 2q, or a equals 2q plus 1. If a is of the form 2q, then a is an even integer. Also, any positive odd integer is of the form 2q plus 1. Example 3. Show that any positive odd integer is of the form 4q plus 1. or 4q plus 3, where q is some integer. Let a be a positive odd integer. We apply the division algorithm with a and b equals 4. Since r is more than or equal to 0 but less than 4, the possible remainders are 0, 1, 2, and 3. That is, a can be 4q, or 4q plus 1, or 4q plus 2, or 4q plus 3, where q is the quotient. However, since a is odd, a cannot be 4q or 4q plus 2, since they are both divisible by 2. Therefore, any odd integer is of the form 4q plus 1 or 4q plus 3. Example 4. A sweet seller has 420 kaju barfis and 130 badam barfis. She wants to stack them in such a way that each stack has the same number and they take up the least area of the tray. What is the number of barfis that can be placed in each stack for this purpose? We are going to find the HCF of 420 and 130. This number will give the maximum number of barfis in each stack, and the number of stacks will then be the least. The area of the tray that is used up will be the least. By Euclid's algorithm, we divide 420 by 130, and we have this equation. 420 equals 130 times 3 plus 30. The remainder is 30. It is not 0, so we continue the process. 130 divided by 30. We get the second equation. 130 equals 30 times 4 plus 10. The remainder is not 0. We continue the process. 30 divided by 10, we get the third equation. We have 30 equals 10 times 3 plus 0. Since the remainder is 0, we stop here. So, the HCF of 420 and 130 is 10. Therefore, the sweet seller can make stocks of 10 for both kinds of barfi.